Hi everyone. Today we're going to learn about arithmetic sequences, and they are related to linear functions because they will find, or you will find, that they have a common difference. Let's take a look at what it actually is. An arithmetic sequence is a sequence that is an ordered list of numbers. The numbers in a sequence are called terms. So here's an example. Each one of these is called a term. In an arithmetic sequence, the difference between consecutive terms is a constant. So take a look. These are consecutive terms. 2, 4, 6, 8, 10. All in order. Those are consecutive terms. So the constant difference is called the common difference. Take a look at the difference here. 2 plus what gets you 4? 2 plus 2. So we're going to add 2 to get to 4. Add another 2 to the 4 and you get 6. Add 2 to 6, you get 8. Add 2 to 8, you get 10. So the common difference here is 2. It keeps going up by 2's. This is a non-example. This is not an arithmetic sequence. Because look what happens. 2 plus 3 gets me 5. 5 plus 3 gets me 8. 8 plus 4 gets me 12. And 12 plus 5 gets me 17. So I'm adding different numbers along here. This is a non-example. This is not arithmetic sequence. All right, let's take a look. Here's an example of a problem. Tell whether the sequence is arithmetic. If it is, find the next two terms. So if it's arithmetic, you're going to see a consistent addition or subtraction of a particular number. So let's take a look. -4 plus 5 would get me a 1. So let's go ahead and grab a pen real quick. And so if I have to add 5 to get to 1. 1 plus 5, add 5 again. 1 plus 5 gets me 6. 6 plus 5 gets me 11. 11 plus 5 gets me 16. So each time I'm adding 5. So this is definitely an arithmetic sequence. Okay? So the first term, A1, is how you refer to it, is -4. Right there. There's the first term. They refer to it as A1. Find the common difference of consecutive terms. What did we notice? It kept going up by 5. So the common difference is a +5. All right, let's look at this part B. Check out these numbers. 3 plus 2 gets me 5. 5 plus 4 gets me to a 9. Oh, no way can this be arithmetic sequence. So this one we would say not arithmetic sequence. It is not an arithmetic sequence. All right. So yes, arithmetic sequence, common difference is 5. No, it is not because it adds different numbers each time. All right, one for you to try. Actually, 4 of them. Pause your video and try out these 4 questions. Decide if they're arithmetic sequence or not. Welcome back. Let's take a look. 3 to 4, add 1. Add 1 to get to 5. Add 1 to get to 6. So this is a yes. It is arithmetic sequence. Let me grab my pen. I'm sorry, this is not working correctly. Yes, it's arithmetic sequence, and the common difference, it doesn't matter. It says, if it is, find the next two terms. So this is 6, the next term would be 7, and the following term would be 8. Let's try. 4 plus 4 gets me 8, plus another 4 gets me to 12, plus 4 gets me to 16. So this one is definitely arithmetic. I'm adding 4 each time. So add 4 to the 16. 16 plus 4 is 20, and then 20 plus 4 is 24. So I'm adding 4 to each number. Let's take a look at number 3. 1 plus 2 gets me 3, so that's a +2. 3 plus 3 gets me 6. Oh, no way. We're adding a different number each time. Not arithmetic sequence. 0 plus 0.5 gets me 2.5, or a half. Take a half and add a half, you get 1. Add a half, you get 1.5. Add a half, you get 2. So it seems to me that we're adding a half each time. So we say yes, that's arithmetic. And 2 plus a half would be 2.5. And then 2.5 plus a half would be 3. So there's our next two terms in the sequence. All right, let's take a look at another question. Now they ask you to graph. To graph a sequence, let a term's position number in the sequence be the x value. The term itself is the y value. So the first term, -4, we write 1, -4. For the second term, we write 2 because it's the second term, and the 1 is the y value. For the third term, here's 3 for the third term, it's 6, so you put that for your y value. Fourth term is 11, so 4, 11. Fifth term is 16, so 5, 16, and you plot your points. And notice it makes a nice line. There's a linear relationship because it continues to go up consistently by 5. All right. Let's have you try this. Graph the sequence, -5, -1, 3, 7. Now remember, always put the position number right here. So if this is the first term, 1 goes there. Second term, x value is 2. Third term, x value is 3. And the fourth term, x value is 4. Pause your video, give it a try. Welcome back. Let's see what we come up with. So obviously we have our terms, the first term, the second term, the third term, and the fourth term. The first term was a -5. The second term was a -1. The third term that I see up here is a 3. And the fourth term I see up here is a 7. So I need to plot these points. I go over 1 and down 5. And number 2, and -1, and 3, up 3, using the coordinates here, 4, 7. So 4, where is that 7? Way up there. And I'm going to grab a line, and I'm going to go ahead and use the line. And we're going to start here, and go through here. And of course it goes on forever. So I have to draw arrows on the end to indicate that this is a line. It would go on and on. All right. Functions. Note that points plotted in example 2 appear to lie on a line. In fact, an arithmetic sequence is a linear function. The common difference is your slope. For the first term, a1, as the point on the graph for the function and equation in point slope form for the function is this. Look at point slope. Ta-da! This equation can be rewritten, and so this is the formula we often use to find out missing terms. And here we go. The rule for arithmetic sequence. This little formula that you see right here, you have to memorize. The first A to N, I know that sounds weird, is a term in the sequence. Any term in the sequence can be found. This is always the first term in the sequence. This is the number of term that you're looking for. Like, let's say you wanted the 100th term, you put 100 in here. If you wanted the 10th term, put a 10 in here. If you want the 1,000,000th term, you put a 1,000,000 in for here. The common difference is that number that you keep adding on or subtracting each time. That's what you do for your common difference. All right. Let's see how you could use this. Write a rule for the nth term of this sequence. So they give you these numbers and they say find the rule. So we use the formula that we have, and A of n is you're looking for a particular term, but let's start off by just plugging in these numbers. Your first term always goes right here, the first term. It's a -4, so I write -4. Plus n minus 1 stays there, and then the common difference. These were going up by 5, so I put a 5 there. Now, the only thing I need to fix this formula up with is I need to figure out if it's asking me to find A100, that means it wants the 100th term. So we're going to put in a 100 for the n. So see how this is A of n, the 100? Look, there's n, there's 100. We want the 100th term. So we go ahead and we do our math. We do 100 minus 1, 99, times 5, and then subtract 4, and you will get the 100th term is 491. All right, let's take a look at another one. Write a rule for the nth term of the sequence. Find A100, which happens to be the 100th term again. So let's take a look. We have this formula. The first term always goes here, so I'm going to write A of n equals, and I put 25 the first term, plus, and I'm looking for the 100th term, so I put a 100 in for my n, minus 1. It's always minus 1. That never changes. And the common difference. 25 plus what gets me to 33? Well, I have to add an 8. So I know my common difference is 8. So now I do 25 plus 99 times 8. 8 times 9 is 72, and then we have another 72, add your 7, so you get 79 plus 25, of course, and these are all A of n. And so finally our A of n equals 5 plus 2 is 7, 2 plus 9 is 11, carry your 1, 817. So I could write this as 100 because I found the 100th term. The 100th term is 817. All right, let's take a look for you guys to do one. Try out this question. Write a rule for the nth term of the sequence. Find the 100th term again. We happen to be using 100 every time, okay? Let's change that a little bit. Let's get rid of that, and let's make it the 10th term. So I would like you guys to do the 10th term, which means you're going to put a 10 in here. Pause your video, give it a try. Welcome back. Let's see how we would have done that. We would write A of n, our 10, because we're looking for the 10th term. And we have our first term always goes in the first place here, negative 6, plus, and we want the 10th term, so we put 10 minus 1, always minus 1. Difference was, I went from negative 6 to negative 3. I'm going up 3, so I'm going to write a positive 3 right here. So we continue, we get negative 6 plus 10 minus 1 is a 9, so 9 times 3 equals, we still have negative 6 plus 9 times 3 is 27 equals, okay, negative 6 and 27, that is going to be a 21, and this is the 10th term. There we go, 10th term, that's what you should have had. Thank you, and I will see you guys tomorrow.